Have you ever sat in traffic next to a big rig and listened to the driver work through what sounds like an endless sequence of gear changes? Each one a deliberate, practiced movement, each one accompanied by a subtle shift in engine note until the truck is finally up to speed and cruising. Because if you have spent any time around heavy trucks, you have probably noticed that the transmissions inside them have been getting more and more complex over the years. Where a truck once had 5 gears, then 9, then 13, then 18. Today, there are trucks rolling off production lines with transmissions offering up to 12, 16, and even 18 automated ratios, managed by computers that make thousands of calculations per minute to decide exactly which gear the truck should be in at any given moment. So why is this happening? Why does a truck need so many gears in the first place? Is it just engineering for the sake of engineering, adding complexity to something that used to be beautifully simple? Or is there a real, practical, financially significant reason why the world's biggest truck manufacturers are pouring billions of dollars into transmission development and why the drivers operating these machines are, for the most part, genuinely glad they did? The answer involves physics, fuel economics, engine technology, driver shortages, and a fundamental shift in what the trucking industry demands from the machines at the center of it. And by the end of this video, you will understand exactly why the number of gears in a truck transmission is not just a technical detail. It is one of the most important variables in the entire business of moving freight. Stick around, because this one goes deep. Let us start with the basics. Why do trucks need gears at all? Before we talk about why trucks are getting more gears, we need to understand why they need gears in the first place. Because the answer to that question is the foundation of everything else. A diesel engine, like any internal combustion engine, produces its power across a relatively narrow band of engine speeds. There's a range of RPM, revolutions per minute, where the engine is operating at its most efficient, producing the most torque for the least amount of fuel. Outside of that range, efficiency drops. Below it, the engine lugs and struggles. Above it, the engine is working harder than necessary and burning more fuel than the situation requires. The problem is that a truck needs to operate across an enormous range of conditions. It needs to pull away from a dead stop with 40 tons behind it, which requires enormous torque at very low road speeds. It needs to climb a mountain grade at sustained speed, which requires a completely different power delivery profile. And it needs to cruise at highway speed for hours at a time, which requires sustained efficiency at relatively modest torque demands. No single gear ratio can satisfy all of those conditions simultaneously. A gear ratio that lets the engine operate efficiently at highway speed would make it impossible to pull away from a stop with a full load. A gear ratio that provides enough torque to get a loaded truck moving from rest would have the engine screaming at dangerously high RPM at highway speed. Gears are the solution to this problem. They are the mechanical interface between the engine and the wheels that allows the driver or the transmission's control system to keep the engine operating in its sweet spot across all of those wildly different conditions. More gears means more opportunities to match engine speed to road speed precisely, which means more time spent in the efficient operating range, which means less fuel burned for the same work done. That is the core of it. Everything else is built on top of that foundation, the early days, and the art of the manual shift. To appreciate where transmissions are going, it helps to understand where they came from. Because the history of truck transmissions is, in many ways, the history of drivers developing extraordinary skill to compensate for the mechanical limitations of the equipment available to them. Early truck transmissions were simple affairs. 3 or 4 speeds requiring considerable physical effort to operate and a good ear for the engine to know when to shift. As trucks got heavier and engines got more powerful, the transmissions grew more complex, but the fundamental challenge remained the same. Keep the engine in its power band across all operating conditions. The American trucking industry developed the standard that defined a generation. The 13-speed and 18-speed manual transmissions that became the backbone of long-haul freight for decades. These transmissions were mechanical masterpieces of a particular kind, robust, repairable, and deeply demanding of the driver operating them. An 18-speed manual transmission requires the driver to manage not just gear selection, but also the split and range positions of the transmission, coordinating clutch operation, throttle input, and gear selection simultaneously, while also managing the truck's speed, following distance, road conditions, and everything else that driving a 40-ton vehicle demands. The skill required to operate one of these transmissions smoothly and efficiently, especially on grades and in traffic, took years to develop and was genuinely something to be proud of. Drivers who mastered the 18-speed manual talked about it the way craftspeople talk about their tools, a perfectly executed float shift, changing gears without using the clutch by matching engine speed precisely to road speed, was a point of professional pride. The transmission was not just a mechanical component, it was part of the craft. But craftsmanship, however admirable, has limits, and those limits became increasingly apparent as the demands on truck transmissions grew more complex. The physics problem that more gears solve. Here is where we need to get into some numbers, because the numbers tell the story better than anything else. A typical heavy truck diesel engine produces its peak torque across a relatively narrow RPM range. On a modern Cummins X15 or a Detroit DD15, that peak torque range might span from around 1,000 RPM to 1,400 RPM, with the engine's optimal fuel efficiency sitting somewhere in that same window. Outside of that range, fuel consumption increases for a given power output. Now think about what happens on a highway run. A truck needs to maintain 100 kilometers per hour, or about 62 miles per hour, while managing varying grades, headwinds, and load shifts. In a transmission with widely spaced gear ratios, the driver might find that the gear that keeps the engine closest to its efficiency sweet spot on flat ground has the engine dropping below that sweet spot on a slight incline, forcing either a downshift that puts the engine above the sweet spot or a continued pull in a gear that has the engine working inefficiently. More gears, spaced more closely together, solve this problem. If the transmission has 12 or 16 closely spaced ratios instead of 9 or 13 wider ones, the driver or the automated system can always find a gear that keeps the engine within a few dozen RPM of its optimal operating point. The engine never has to lug significantly, it never has to over-rev significantly. It spends more time in its sweet spot, burning less fuel for the same work. The fuel savings from this sounds modest in percentage terms. We are typically talking about improvements in the range of 3 to 7% depending on conditions and comparison baseline. But in trucking, where a single truck might burn 120,000 to 150,000 liters of fuel per year, a 5% improvement translates to 6,000 to 7,500 liters of fuel saved annually per truck. Multiply that across a fleet of 500 trucks and the number becomes so large, it stops feeling like an efficiency gain and starts feeling like a business transformation. The automated transmission revolution. Here's the development that changed everything: the shift from manual transmissions requiring skilled driver input to automated manual transmissions, or AMTs, that handle gear selection electronically. An automated manual transmission is not the same as the automatic transmission in a car. It is still a mechanical gearbox with discrete gear ratios, but the clutch actuation and gear selection are handled by actuators controlled by an electronic control unit rather than by the driver's hands and feet. The driver still has override capability, but in normal operation, the system manages shifts autonomously, making decisions faster and more precisely than any human can. The two systems that have defined this revolution are the Eaton-Fuller Advantage series and the Allison Automatic, with the Eaton Endurant and the ZF Traxxon also playing major roles globally. Each of these systems represents years of development and refinement, and each of them has fundamentally changed what is possible in terms of transmission efficiency and precision. The Eaton UltraShift and its successors, for example, use engine data, vehicle speed, road load calculations, and GPS topographical information to predict what gear will be needed not just right now, but in the next few seconds. If the system sees from the GPS data that a grade is coming in half a mile, it can begin preparing for the downshift before the grade is even visible to the driver. The result is smoother operation, better fuel efficiency, and less drivetrain stress than even an experienced driver could achieve manually. And this is the point that sometimes surprises people who romanticize the manual transmission era. The automated systems are not just more convenient, they are genuinely more efficient. Testing by manufacturers and independent fleet operators consistently shows that AMTs improve fuel economy compared to even skilled manual drivers running the same routes in the same conditions. The computer does not get tired, it does not have a bad day, it does not take a slightly different line through a gear change at 3 a.m. when it has been driving for 8 hours. It makes the optimal decision every single time. Why more ratios make automated systems even better? Here's where the increasing number of gears and the rise of automated transmissions come together in a way that multiplies the benefits of both. An automated system with 12 or 18 ratios can optimize far more precisely than one with 9 or 10. The additional ratios give the control system more options to work with, more points on the map between full torque at low speed and light cruise at highway speed, and more opportunities to keep the engine in its optimal zone. The Eaton Endurant, for example, offers 12 forward speeds in a package that is actually lighter and more compact than the 18-speed manual it replaces. Because modern engineering and materials science allow for more ratios and less physical space than was possible a generation ago. The ZF Traxxon, used extensively in European trucks, offers up to 16 ratios and a control system sophisticated enough to factor in trailer weight, road gradient, and ambient temperature into its shift decisions. Volvo's iShift system, one of the early pioneers of the AMT revolution in heavy trucks, now offers a version called the iShift Dual Clutch, which uses two clutch packs to enable seamless power, uninterrupted upshifts, something that was simply impossible with a conventional single-clutch manual. The truck accelerates without the brief power interruption that every gear change in a traditional transmission creates, which is particularly valuable in stop-and-start traffic and on grades where momentum is precious. Each additional ratio is another tool in the system's toolkit. And in the hands of a sophisticated electronic control unit processing data from dozens of sensors dozens of times per second, more tools means better outcomes, better fuel economy, smoother operation, less drivetrain wear, and longer component life. The driver shortage connection nobody talks about. There is another dimension to the shift toward more gears and automated transmissions that does not get nearly enough attention in the technical discussions, and that is the acute shortage of qualified truck drivers across North America and Europe. Learning to operate an 18-speed manual transmission competently takes significant time and practice. Not everyone who wants to drive a truck has the patience or aptitude to master the double clutch, the float shift, the split and range management, the hill hold technique, all of the physical and cognitive skills that a seasoned manual driver deploys without thinking. And in an industry that is desperately short of drivers, the manual transmission skill barrier is a genuine problem for recruitment. Automated transmissions with more ratios and smarter control systems dramatically lower that barrier. A new driver in a modern AMT-equipped truck can focus on the genuinely important skills: road awareness, vehicle dynamics, load management, hours of service compliance, customer interaction, without simultaneously having to master a complex mechanical skill that takes years to develop. They get up to speed faster, literally and figuratively, and they feel more confident sooner. Fleet operators have noticed this. The feedback from fleets that have transitioned to AMT-equipped trucks consistently includes reports of faster driver onboarding, lower rates of drivetrain damage from improper shifting, and improved driver retention, because drivers who feel competent and in control of their equipment are less likely to quit. There is a reasonable argument that the automated transmission has done more for the truck driver shortage than any recruitment campaign in the industry's recent history. Not by replacing the driver, but by making the driver's job accessible to a wider range of people, and by making it less physically and cognitively demanding in ways that matter for long-term sustainability in the profession. The fuel economy, arms race, and where transmissions fit. It would be impossible to talk about why trucks are getting more gears without talking about the broader fuel economy arms race that the trucking industry has been running for the past 2 decades, because transmission development is one piece of a much larger puzzle. Aerodynamics have improved dramatically, with roof fairings, side skirts, boat tails, and gap reducers cutting the aerodynamic drag of a modern truck-trailer combination by meaningful percentages compared to a vehicle from 20 years ago. Engine efficiency has improved through better combustion management, improved turbocharging, waste heat recovery systems, and the precise fuel injection systems that modern common rail diesels use. Tire technology has advanced, with low rolling resistance compounds and better inflation management systems, reducing the energy lost to tire deformation at highway speed. Even lubricants have improved, with synthetic oils reducing internal friction in ways that add up over millions of engine revolutions. Transmission development fits into this picture as one of several overlapping improvements, each contributing a few percent here and a few percent there, until the cumulative effect is a modern truck that delivers dramatically better fuel economy than its equivalent from 15 years ago, while carrying similar or heavier loads at similar or higher speeds. The fuel economy targets being set by regulators, particularly the EPA's Phase 2 greenhouse gas standards in the United States, and the equivalent regulations in Europe, are pushing the entire drivetrain development program forward with urgency. Meeting those targets requires ringing efficiency gains from every component in the power delivery chain, and the transmission is one of the most accessible places to find those gains because the technology to improve it is mature, proven, and available now. The predictive systems that are changing the game. Here's one of the most impressive developments in modern transmission technology that most people outside the industry have never heard of. And it is worth spending some time on because it represents a genuine leap forward in what these systems can do. Modern AMTs and high-specification trucks are increasingly being integrated with GPS and topographical mapping systems to enable what is called predictive cruise control and predictive shifting. The concept is straightforward in description, even if it is sophisticated in execution. The transmission control unit knows from GPS and map data exactly what the road ahead looks like. Every grade, every curve, every descent for the next several kilometers is already in the system before the truck gets there. Using that information, the system can optimize its behavior proactively rather than reactively. Approaching a long downgrade, the system can shift into a gear that will use engine braking effectively, managing speed on the descent without touching the service brakes, saving brake wear, and allowing the truck to carry momentum into the next uphill section. Approaching an uphill grade, the system can allow the truck's speed to build slightly in the kilometers before the grade begins, using that stored kinetic energy to reduce the severity of the power demand at the base of the climb. Scania's active prediction system and Volvo's IC are two of the most developed implementations of this technology, and independent testing has shown fuel savings of up to 3% from these systems alone, on top of the savings already achieved by the AMT itself. 3% from software and GPS data with no change to the hardware at all. It is efficiency extracted from information rather than from engineering, and it is one of the most cost-effective developments in modern trucking. What drivers actually think. Now, let us be honest about something, because no discussion of the shift from manual to automated transmissions in heavy trucks is complete without acknowledging that not everyone has been enthusiastic about it. The generation of drivers who built their careers around mastering the 18-speed manual often had complicated feelings about the automated systems. There was, and in some corners of the industry still is, a sense that the skill and craft of manual shifting was part of what defined a professional driver. That removing it from the equation was not just a technical change, but a cultural one. That the computer doing the shifting meant the driver was somehow less skilled, less valuable, less professional. Those feelings are understandable and worth respecting. The craft of manual transmission operation in a heavy truck was genuinely impressive, and the drivers who mastered it had every right to take pride in a skill that took years to develop. But the practical reality, as experienced by drivers who made the transition, tells a different story. Drivers who spent their early careers in manual trucks and then switched to AMT-equipped vehicles consistently report that the switch was positive, not because the driving became easier in some diminishing sense, but because the mental and physical energy previously spent on gear management became available for the parts of the job that actually require human judgment. Traffic reading, road condition assessment, customer interaction, route management. The things that a computer cannot do and that a skilled driver does exceptionally well. The transmission got smarter so the driver could get better at everything else. And in a profession that demands more from its practitioners every year, that trade turns out to be a good one. The road ahead, so where does this go from here? Because the development of truck transmissions has not stopped, and the direction it is heading is worth understanding. The integration of transmissions with electrified powertrains is the next frontier. Hybrid heavy trucks, combining a diesel engine with electric motors at the axles or integrated into the drivetrain, create new demands on the transmission system and new opportunities for efficiency. Some configurations eliminate the need for a traditional multi-speed gearbox entirely because electric motors deliver full torque from 0 RPM, eliminating the fundamental problem that gears exist to solve. Others use a simplified transmission in combination with electric assistance to achieve efficiency gains across a wider operating range than either technology could achieve alone. Fully electric heavy trucks, which are beginning to appear in real commercial operations in short and medium-haul applications, typically use single-speed or two-speed reduction gearboxes rather than multi-speed transmissions because the electric motor's torque curve makes the complex ratio management of a traditional transmission unnecessary. If electrification continues to advance in heavy trucking, the multi-speed transmission in its current form may eventually become a technology specific to long-haul diesel applications, used precisely and effectively in the applications where it fits, while other powertrain types take different approaches. But for the foreseeable future across the vast majority of global freight moved by diesel-powered heavy trucks, the transmission will continue to get more sophisticated, more connected, and in certain configurations, more numerous in its ratios because the physics have not changed. The need to keep the engine in its sweet spot across a wide range of operating conditions has not changed, and the value of doing that as precisely and efficiently as possible has never been higher. The bigger picture? So why are trucks getting more gears? The real answer is that more gears are the most practical, most proven, most immediately available tool the industry has for squeezing more efficiency out of a powertrain that the world's freight economy depends on running, as well as possible. Every ratio is another opportunity to match engine speed to road conditions with precision. Every additional data point feeding the control system is another input that helps the transmission make a better decision. Every improvement in shift quality and timing is fuel saved, brake wear reduced, drivetrain stress lowered, and driver energy preserved for the parts of the job that actually need it. The truck with 18 gears managed by a computer that knows what the road looks like for the next 10 kilometers is not a more complicated version of the truck with 9 gears managed by a driver's left hand and right ear. It is a fundamentally more capable machine doing a fundamentally more demanding job in a world where the margin between profitable and unprofitable in freight transport is measured in fractions of a percent. And the drivers operating these machines, the ones who have made the transition and figured out how to use what the modern transmission gives them, will tell you that the extra gears are not a gimmick. They are the reason the truck does what it does, the way it does it every single day, mile after mile, load after load, without complaint and without compromise, which is exactly what trucking has always demanded of its machines. How many gears do you think is too many, or do you think the more the better? Drop it in the comments below. We genuinely want to know. Thanks for watching Titan Haulers, and remember to subscribe for much more.